We're going to talk about sigma and pi bonds. Sigma bonds are bonds that occur along the axis, just where you would expect them to occur. For instance, if we look at this molecule C2H6, the way we've been drawing it is we draw those single bonds, and we draw them directly between the carbons and the hydrogens, indicating that they're right along this axis. Okay, that they're directly between the carbon and the hydrogen. When this happens, and that is what happens with single bonds, they're called sigma bonds. So this is when they bond along the axis. Not surprisingly, you're probably thinking, yeah, so don't they always? Well, no. They do for single bonds. So sigma bonds are found in single bonds. But what happens when we get to a molecule now that has double bonds? So if we draw this molecule here, C2H4, we're going to see something a little different. All of the sigma bonds, single, this is a sigma, 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 but the double bond acts a little differently. The first two electrons are right in between the carbons like you might expect, but these second two electrons are in a different place. If we look at a pi bond, the bonding, the overlap between them is actually above the axis and below the axis. Sigma bonds occur right along the internuclear axis, the axis between the two nuclei. But here are your nuclei, and here's your internuclear, and these two electrons are bonding above and below. A molecule of C2H4, I don't know if you can see here, but I'm going to make these sigma bonds blue. These are your single bonds, okay? These are all single. That's this overlap right here. These overlaps right here that occur between the carbons and hydrogens. Okay, those are single bonds or sigma bonds. This first pair of electrons here is this overlap right here between the two. But this last pair of electrons, this sec right here, is actually overlapping here and here. Basically, there just isn't room for all four electrons right between the two carbons. So the first two bond along the axis, and the next two bond above and below. So when I have a double bond, I have one sigma and one pi bond, which just tells us that two of the electrons are bonding right along the axis, and the other two are bonding above and below the axis. I have a triple bond. Well, again, let's look at the single bonds. So that's here. These guys right here. That's this overlap right here and right here. It's happening right along the axis between the carbons and the hydrogens, right along your internuclear axis. This first pair of electrons also is right here along that. They're calling that a sigma bond. But the next two are above and below. And then the last two are kind of front and back, but again, above and below or outside the internuclear axis. So when you have a triple bond, you have one sigma and two pi. So if we have some sort of a more complicated atom, or we'll just think of a simple one. What if I look at SO3? We'll go ahead and draw the structure. Okay, we'll give it its electrons. And if I asked you in that molecule, how many sigma bonds does it have, and how many pi bonds does it have, you would say, well, there's a sigma, there's a sigma, and there's a sigma. So I have 3 sigma bonds, but this double bond has a pi, so I have 1 pi bond. So that has 3 sigma and 1 pi. And that's how you do sigma and pi bonds.